Estimate the area under the graph of g of x equals the square root of x from x equals 0 to x equals 4 using 4 approximating rectangles, first using right endpoints and then using left endpoints. We know what the graph of the square root function looks like. It roughly looks something like this. And we are looking at going from 0 to 4. So if we say this is 4, and we can even label these 1, 2, and 3, then our region is this region S, and we can shade it in, which I am enjoying actually quite a bit, to be completely honest with you, shading in with this highlighter tool. I like the colors. A lot of the videos I make don't have colors, so I am enjoying this. All right, there we are. So we have our region, and we want to use 4 approximating rectangles, so we need to cut it into 4 strips. And we'll do that by putting up vertical line segments at 1, 2, and 3. And then we want to use right endpoints and then left endpoints. Let's actually draw in the rectangles with the right endpoints. So it's going to look something like this. Right, for each interval, we look at the right endpoint, and where the graph hits that, at that function value, that is going to be our height. So we've got our 4 right rectangles there, and so we can write r sub 4. And in the last problem, we actually, instead of writing out base times height plus base times height plus base times height, we recognize that all of the bases were the same, so we can put the base out front. And in this case, the base is 1 for each of those intervals. And then we can take all of the different heights and put them on the inside. So the heights of these rectangles are the function values at the right endpoints. The function is the square root of x, and our right endpoints are going to be 1, 2, 3, and 4. So we're going to have the square root of 1 plus the square root of 2 plus the square root of 3 plus the square root of 4 for our right endpoints. And that is going to be an irrational number because we've got the square root of 2 and the square root of 3 in there. But we can use a calculator to approximate it, and we get about 6.146264. I seem to have chosen 6 decimal points for my approximations. Oftentimes, if you're doing the homework will tell you exactly how many places to round to. But I've just gone with 6 because I think it's better to have more than fewer. Now, if we wanted to use left endpoints, we would still have a width of 1 for each of them. But when we are looking at the heights, so for this strip here, if we use the left endpoint, it's actually going to look like that. So let me draw in the heights of these rectangles. Using the left endpoints, you can see that the first one was an overestimate, and this is going to be an underestimate because it includes less regions than the whole of S. And so if we wanted to write out the heights, instead of taking the function at 1, 2, 3, and 4 for the right endpoints, we're actually going to be using the left ones. So it's going to be at 0, 1, 2, and 3. So we're going to end up having inside our parentheses or bracket the square root of 0 plus the square root of 1 plus the square root of 2 plus the square root of 3. And that is approximately 4.14624. The interesting thing here is we've got the same fractional portion, but the reason there is because these two quantities are equal to each other, except we've replaced the square root of 4 with the square root of 2. So basically we've taken 2 and gotten rid of it and replaced it with 0. So we have subtracted 2 from this estimate. So we know that the actual answer is somewhere between 4.14 and 6.14. If we wanted to get better approximations, we could use more rectangles. We could use 10 rectangles, 100 rectangles, 1,000 rectangles. That would eventually help us figure out what our limit is. But just in case you're curious, I will tell you that the actual limit ends up being 16/3 or 5 1/3. That is the actual area of that region, which is something that we will be able to calculate soon, even without having to do all sorts of crazy approximations, doing calculations with 100 rectangles or 1,000 rectangles. No one wants to actually do those calculations, and so we will eventually be learning better ways to calculate these. But for now, the approximations are what we have.